So guys, this is class 10 physics chapter number 1, that is light. In my previous one, I have explained you what is the reflection of light and the general terms associated with spherical mirrors. So in the optics, what is optics? Optics is a branch of physics which deals with the phenomenon of light. The study of light is called optics. So second part of this optics is that refraction. So today we are going to discuss what actually refraction is. Refraction. You say refraction means what? Generally, the speed of light, suppose if a light travels in air, it has one speed. And if the same light travels in any denser medium, maybe a glass, maybe a water, so the speed of light will differ. Means if a ray of light enters from one medium to another medium, it slightly bends. For example, you take a glass. That should be a glass material, transparent material. Pour half water in that glass. Now, according to science, half the upper part where there is no water, that is filled with air, and the lower one is filled with water, isn't it? Now, if a pencil or scale or any stick which is straightly, you just put it in the slight inclined in a glass, what you will see? The straight scale, when it is crosses from air and when it is crosses from air to water, at the edge of the water you will see slightly bending of that stick, though it is straight, but in the denser we are seeing some bending. See, this bending property of light is called refraction. If a ray of light enters from rarer medium मतलब वो medium जो खाली रहता है. When a ray of light enters from rarer medium to denser medium क्या होता है? जहाँ भरा होता है. So there what happens, you will see a slightly there is a bend of light when it crosses from one medium to another medium. Now suppose this is glass. Okay, so the above one is air. Air means rarer medium, khali wala, and this is completely glass, that means denser medium, bhara hua. Now what happened? When a ray of light, this incident ray, when crosses, the point in the glass where it crosses, you put a point and from there draw a perpendicular that is called normal line. You draw a normal line here. Now, what happens? When a ray of light travels from rarer medium to denser medium, what happens? It will slightly bend towards the normal. Actually, it should go in straight like this, but it will go in this manner. You see, we have seen slightly. Actually, the straight line should be like this, but once when it is crosses from rarer medium to denser medium, it slightly bends towards the normal, and this is called normal line. Same vice versa. When the ray of light crosses from denser medium to rarer medium, it will go away from the normal. It will bend away from the normal. Now we have seen a rectangular glass slab. Let me explain you this with example. A rectangular glass slab, पूरा एक rectangle का glass slab होता है. In the laboratory we will do that. So this is rectangular glass slab. Okay, this much thickness. Now what happens when a ray of light comes here? Now we will make it more slant. If a ray of light crosses like this, at this point you just make a normal. Okay. Now what I said, this is rarer medium and this is denser medium. So it will bend towards the normal. Again here you draw one more normal line. Okay. Then what happened? I told you when a ray of light crosses from rarer medium to denser medium, it will slightly bend towards the normal. Again, when the ray of light from denser medium to rarer medium crosses, it will bend away from the line, away from the normal. So it will again it will go like this. Okay. Now this is what phenomenon in the lab we can say, we can see this. Now what happened actually? Here this is a line, this is incident line. So the angle which is formed from the normal, it is called angle of incidence. I means angle of incidence. I means angle of incidence. Now, so this is refraction. So this angle is called angle of refraction. Angle of refraction. So this is called also. But that angle of reflection, again it crosses to the rarer medium. In this case, this is called E. E means angle of emergent. E-M-E-R-G-E-N-T. The angle of emergent. Now you see here, when it crosses from rarer to denser, angle of incidence is greater than angle of reflection. But again, when it crosses from denser medium to rarer medium, angle of reflection is less than angle of emergent. But what the magic is, angle of I is always equals to angle of E. It will be equal. If you do this practical perfectly, your calculation will come. Whatever angle you got, same angle emergent it will come. Now one more thing here is to remember that suppose a glass nahi hota, what could have happened? This line could have gone like this. ऐसे चले जाता, isn't it? But if suppose a straight line, if there was no glass, then what would happen? The light could have gone through like this. Rectilinear propagation of light. What is rectilinear propagation of light? We have learned in the lower classes that a light always travels in a straight line. That property is called rectilinear propagation of light. But here, since the glass is there, so there got some obstacle in the speed of the light, so it differs, the direction differs again here. Now actually the original line should be like this, but it displaced to this point. So this distance, this displacement is called lateral displacement. What is this distance is called? This displacement, actually the line has displaced to here, so this point is called lateral displacement. Remember this. Lateral displacement. Now here, we know light consists of 7 colors. Our great scientist Sir Isaac Newton has discovered this. Light is composed of 7 colors, and 7 colors we have right from the down: violet, indigo, brown, green, yellow, orange and red. See here light, though it travels in a straight line, but it has the wave property. Light travels in slightly wave. So here the wave is slow, very less, minimum. Here bit maximum, like that. If you go upper, the wavelength increases. So since it has a higher wavelength, so red can be visible in any condition, and that is why red is kept as a danger signal, because in any cloudy weather, whatever the weather condition, weather atmosphere, we can easily see red color better than rest of the colors. So red as given as a danger color, a red cross color, whatever it is. Now here minimum wavelength is for violet. So if a single ray, any one ray, if suppose violet ray is crossing here, then what happens? We can see the displacement maximum. If indigo, little bit lesser than this. So in a same manner, if the red crosses with slightly displacement, means your lateral displacement will be very small, very small. So इट्स जस्ट वाइस वर्सा, अगर ये कम है तो लैटरल डिस्प्लेसमेंट ज़्यादा होगा, अगर ये ज़्यादा है तो लैटरल डिस्प्लेसमेंट कम होगा. दिस इज व्हाट रिफ्रैक्शन ऑफ लाइट. नाउ द सेकेंड पार्ट ऑफ दिस इज कॉल्ड, वी विल लर्न रिफ्रैक्टिव इंडेक्स. रिफ्रैक्टिव इंडेक्स. व्हाट इज रिफ्रैक्टिव इंडेक्स? You know, same thing we will continue. Suppose this is a medium, a ray of light travels here and it bends towards the normal. Okay. Now what is refractive index? Here, when in the air, speed of light in air is 3 into 10 to the power 8 meter per second. It travels in this speed. Now what happens? The same speed of light when travels in air, it crosses to another medium. What happens? The speed will differ. Speed थोड़ा घट जाएगा, because here the hole is भरा हुआ था, denser था. Automatically speed will be like that as in the previous case. Speed घट सकता है, बढ़ सकता है. It varies. So कितना vary होता है? The ratio of this to this is called refractive index, and generally we will call इनका abbreviation word होता है mu. लोग इसको ऐसे भी लिखते हैं. So we will pronounce this as mu. Mu. Suppose this is medium 1 and this is medium 2. So what is refractive index of this? So we will write refractive index of second medium compared to the first medium. So don't think it is 21. It is second medium compared to the first medium is equal to speed of light in medium 1 divided by speed of light in medium 2. So this ratio is called refractive index. Suppose we know that the speed of light in air is 3 into. Now here one more thing, always mu is the inversely proportional to velocity. Mu is always inversely proportional to velocity. तब क्या होगा? दैट मीन्स इन्वर्सली प्रोपोर्शनल ऑफ वेलोसिटी का मतलब होता है mu2 is equals to the velocity of 1 and mu1 is equals to the velocity of 2. You just keep remember this one. Now we know that speed of light in air is 3 into 10 to the power 8 and speed of light in glass is 2 into 10 to the power 8 meter per second square. Now I will write here, suppose this is air and this is glass. So we will write mu like this. Glass over air is equals to, we will take out the ratios. Okay. mg by ma. We will, mg का क्या होता है? va वेलोसिटी है क्योंकि प्रोपोर्शनल है और ये इसका प्रोपोर्शनल. हम mg में वेलोसिटी ऑफ एयर लेंगे और ma में वेलोसिटी ऑफ एयर लेंगे. तो वेलोसिटी ऑफ एयर कितना था? 3 इंटू 10 टू दी पावर 8 था, इंटू मीटर पर सेकेंड स्क्वायर, मीटर पर सेकेंड था. और ये ग्लास में कितना था? 2 इंटू 10 टू दी पावर 8 मीटर पर सेकेंड था. Now what happened? This whole thing cancels out. So we got 3 into 2. 3 into 2 means 1.5. Means क्या है? The refractive index of glass is 1.5. Means what does this mean 1.5? The speed of light in air जितना था उससे कंपेयर करते स्पीड ऑफ लाइट इन ग्लास में इतना गुना कम हो जाता है. So 1.5 times decreases the speed of light compared to air to glass. तो ग्लास में इसका स्पीड एयर की तुलना से इतना घट जाता है, 1.5 times decreases in glass. So I think in your textbook for various materials various refractive index is given, so उतना वो कंपेयर करते हैं एक मीडियम से दूसरा मीडियम पर उतना घटता बढ़ता है. So this is called refractive index. Now we will go to the second part.